Welcome. In this series of videos, we will cover the design and implementation of a project, from initial design through coding and development to testing, using the PowerBasic Windows compiler. Today we will continue our project to look at the use of text prediction software. This was our application at the end of the last video. We have fed a large amount of training data into our system. If we load that up, it will load very quickly, and then it will allow us to type text into the text window. And after the second word has been typed, it will give us a list of possible words, starting with the most likely word at the top of our list box. And as each word is selected, it allows us to select a next word. We have created this training data using the subtitles of all the PowerBasic training videos, and this is working reasonably well. The more training data the system has, the better the list of possible words that will appear on the right-hand side of our dialog. Now that we have this training data in the system, what else can we do with it? Well, today we're going to add a new icon on our toolbar to allow us to generate text. So let's go back to the code and set that up. Since we create our toolbar in a separate include file, that's the file we're going to be amending first of all. We have at the moment 3 items on our toolbar: an add button, a save button, and a load button. We're going to add a 4th button now. This we'll call ID process, and we will create an icon to be used for this button. And we will load it into the system using the resource icon command. This icon can now be loaded into our image list. And now that it has been added to the image list, we can now add it to the toolbar. So there is our 4th icon added to the toolbar. As we don't want to start processing until the training data has been loaded, we want to initially disable this processing icon. And we can achieve this by using the toolbar setState command. Its first parameter is the handle of the dialog. The second parameter is the handle of the toolbar. Our next command is telling the system that we want to use the ID process command. This is the one we have just added. And the final parameter is the state we want to set this button to, in this case, disabled. This will leave the button grayed out and non-selectable by the user. So now that we've actually amended our toolbar include file, if we run the application now, we will see we now have our 4th icon on the toolbar, which is currently grayed out. So that's the groundwork set for our toolbar. Next, we need to make some changes to the main processing code. This is to allow us to make use of an existing function. When the user types in 2 words and then presses the spacebar, the system then looks at the array of data it has and suggests possible words, displaying those on the list box on the right-hand side of the dialog. If we look at the process text change function, we'll see in here this is where we pick up the first word the user has typed and also the second word. We're then calling a function called suggestWord, passing it 3 parameters. This is a function we're going to change to make the function a little more usable. The purpose of this function at the moment is to suggest a word and also to populate the list of possible words in the list box on the right-hand side of the dialog. I'm going to split this functionality out so that the population of the list box is done outside of this function. So now we're preparing the 2 arrays to hold the word and the word count. So we're going to change the suggested word function. Firstly, to return either a true or a false. If it returns true, then we have populated the 2 arrays. If it returns false, then there is no data to populate into those arrays. And on our parameters list, our first parameter is now going to be the phrase. This will be the first and second words. The second parameter is the string word array. And the final parameter is the long array holding the word counts. Next, we're resetting the word list. This is a list box on the right-hand side of the screen. And then we're looking through each of the elements within the word array to see if it is not blank. This array has already been sorted to ensure that the most prevalent word is at the top of the list, and the listbox command will add each of these words in turn to our listbox. So as we've now made a change to the suggest word function, we're now going to have to change that function itself. First of all, we will change the parameters. This now matches the call to the function, the first parameter being the phrase, and the next two parameters being the arrays. So previously within this function, we dimensioned these two arrays. We no longer need to do this as these two arrays are coming in on the parameters list. So let's, for the moment, comment out these two lines of code where the arrays are dimensioned. The part of the code which scans the array is unchanged. However, we don't want to reset the listbox in this piece of code because it's going to be done outside of this function. So for the moment, we'll comment out that line of code as well. And at the end of the function where we add the results to the listbox, this is no longer required within this particular function. So we're going to comment out these lines of code, and we're going to put in function equals true to say it's got to the end of the function. And if we look back up to the process text change function, we'll see in here we're now using a new variable long row to step through each of the elements within our result. So we'll need to declare that new variable at the beginning of our code. And there it's added to the list of declared variables. So we've changed some of the functionality of the application, but from the user's perspective, it should work exactly the same for the suggested words. So let's try it to make sure we haven't broken anything. And if we load our training data, it's loaded, and we can now type our text. And there are the suggested words appearing quite normally. So the functionality of the application as a whole is unchanged, but we have now changed the suggested word function to make it more flexible. The next thing we're going to do is we're going to enable the Start Processing icon on the toolbar once the training data has been loaded. So once more, back to the code. So if we look at the event handler for our dialog, the callback function. And within here is an event for load where we'll load the arrays with our training data. So if the training data has been loaded successfully, at that point we can now enable our toolbar button by using the toolbar set state command, taking the usual expected parameters, the dialog handle, the handle of the toolbar, and which button we wish to activate or deactivate, in this case the process button, and what state we want to put it into. In this case, we want to enable it. So if we run our application now just to test that functionality, initially the button is grayed out. We click on Load Training Data, and the Start Processing button is now enabled. It doesn't do anything because we haven't handled that event yet. So creating that event in our event handler is the next task. So we're now going to add a new event to our list of events. And there is our new process event. We're going to create a new function to do our processing, and we'll call it Run Processing, taking two parameters. The first parameter is the handle of the dialog, and the second parameter is the handle of the text input box. This is where we wish to put our data. So here is the skeleton of our new function taking in its two parameters. I've created a number of local variables. First of all, a seed string variable. This is going to be the word or words provided by our user. I want to display to the user an input box to allow them to type these two words in. We're then going to use a text variable to build up the text from our data arrays. And then we're going to loop round and go into that several times. And we're going to create a loop count variable to count how many times we're going to iterate round this loop. And there will be a word suggested by the system, which will be added to the text the user can see on the screen. And we're going to use a final variable to store the last two words on that dialog. So next we will prepare our two arrays. This is the reason we wanted to move the dimensioning of these arrays outside the suggested word function. And we're going to set up a loop count of 50, so it's going to have 50 attempts at putting words in this text box. Next, we're going to populate the prompt the user is going to see. Enter 2 words separated by a space. We can then populate our seed variable by using the input box. This will display a simple input box to the user, prompting them to key in 2 words. And we will store the value that they have keyed in this seed variable. Our next task is to empty out the text box on the dialog that all our data is going to go into. Next, we're going to do our first call to the suggested word function, passing the expected parameters of the seed and the 2 arrays. This function, now amended, will return a true or a false. If it returns true, then we have data within these 2 arrays which we can then use to populate into the text box. The string word array will contain a list of words. We then have to decide which word we're going to pick. We could pick the one at the top of the array, which is the most likely word. But I'm going to break out the word to pick into a separate function called pickWord, passing it the 2 arrays. This will give us more flexibility. If no words are returned, then we will exit the function immediately. So before we do the loop, let's create this new pickAWord function. So here is our new function. This is not going to be a complicated function. It takes the 2 arrays in as parameters, and we're going to set a top value, which is the element of the array we're going to pick. And for the moment, we're going to pick a random number between 1 and 5. And our variable word suggested is initially blank. And next, we're testing the selected element of our word array. If this is not an empty-line string, then we're making that the word that has been suggested, and then reseeding the top value, and then returning the value of the word suggested. So because we're using random numbers, let's set the randomize at the beginning of our application. So if we go back to the pb main function, and we've now added the randomize command to the beginning of our application. This will seed the random number generator with the current number of seconds since midnight. So each time the application runs, it will get a different seed. So before we go further, let's check to see if the application will pick up 2 words. If we run the application now, click on the load training data, our start processing is now enabled. If we click on that, we get the text input box. If we enter our 2 words and click OK, the application at the moment does nothing, as we still have more code to put in. But we've proved the text input box will be generated. So once more, back to the code. So once we have returned the data from suggested word, we now have to look to see if we can put the data on the text box control. So we can use the control set text command to set the value of our text field equal to the text variable which we have been building up. So let's try running that now to see if we get the first word on the screen. We click on load training data, we click start processing, and we type the first 2 words in. And there we have the first generated word. It now says, today we can. So we've proved we can get a word out of the system and place it on the screen. Let's see if we can add more words. Our loop count is set currently to 50, so it's going to have 50 attempts at adding words to our text. So if we had a true value returned initially from this, and we set the first seed, we now want a for next loop. This will go from 1 to the loop count value. So here is the beginning of our for next loop, going from 1 to the loop count value. And we are initially redimensioning our 2 arrays to ensure that the arrays are empty for each iteration. This allows us to have a different selection of words each time round the loop. Next, we are getting the last 2 words from our existing text, using the parse command with negative values. And the delimiter we're using is the space. So the -1 gives us the last word, and the -2 gives us the second last word. So adding these 2 together with a space between them gives us the last 2 words. This can now be used to feed into the suggest word function. So we can call suggest word, passing the last two words as our phrase, and also the two empty arrays, the word array and the word count array. And the word suggested will be picked from the values put into those two arrays. And we will then add to our text variable the word suggested. So let's try running the application now to see how well it does. So we click on Load Training Data and we start processing. And we can see that we now have possibly the beginnings of a sentence. Today we have created a number greater than 0. We can now see the dialogue is much longer. Obviously, as you can see the code in this system, you'll see there is very little intelligence in the system itself. The only implied intelligence is in the words we've stored in our training data. But despite the fact the application has no knowledge of the English grammar or the construct of a general sentence, it's still doing not too bad. Let's try running it once more. We've got more data now. Today we're already getting a value to whatever it is the name suggests. Now this is where it obviously falls down. Because the application has no knowledge of the construct of a sentence, although the words themselves make sense and small numbers of words together will make sense, as a grammatical description of English, it falls significantly short. However, if we extrapolate forwards and think how the large language models actually work, what we get to see when we type in text into one of these large language models is something coming out the other end which makes a great deal of sense. However, what we do not get to see in these large language models are all the paragraphs and sentences that do not make a great deal of sense, because these are filtered out by the system. Many sentences may well fail the checking that the system does on the construct of how a sentence is put together. So in summary, what we've achieved in our application is we've taken a large amount of training data and formed it up into a structured array. This array holds a collection of 3-word phrases. And in today's video, we've taken those 3-word phrases and attempted to use them to construct paragraphs of text. While there is no implicit intelligence or knowledge of the structure of a sentence or any English grammar, it does produce something that is edging towards readable text. It will need a fair bit more work to get towards something that a large language model will achieve. However, hopefully you have found this interesting and maybe useful in your own applications. But that's it for today. Thank you for watching.